So in the previous video, I said that there are two steps for how an assembler language works. Or I'll rephrase that, for how an assembler program works. Another way of saying this is two stages. Another way of saying this again, instead of saying two steps or two stages, is two pass. And we're going to look at the two pass assembler. Now, step one. What happens when the assembler runs is the following. Number one is, let's imagine we've got code like print hello. And let's imagine, like any good program, you've got a comment, which remember does not run, but is used for other programs to understand what the code does. What will happen is, when the assemblers run, this comment is removed from the code to make the code smaller. So removal of comments. The second thing that happens is a creation. Remember, God made the world, so create, keep that in your mind. Creation of symbol tables. And these symbol tables, so imagine symbol table, and what happens is it literally stores binary code for symbolic names and tables. So it creates, let me say that again, a symbol table. You don't really need to understand the logic of what it actually is, just be able to remember symbol table containing binary code for symbolic names and tables. It also creates something called a literal table if the program has used constants in their code. Now, constants are basically variables which don't change in runtime. So what I mean by that is this. Oops, my keyboard has broken. Can I use the backspace key right now? Okay, I don't know the rest of pi off by heart. But the point is that pi never changes. So that's a constant. It's a variable which will never change in a program. Another constant you can have would be tax, like in a accounting program. And it wouldn't change during runtime. Or another constant which you would have would be, let's imagine you're a hotel and you have a certain number of rooms. It's like a variable, but it doesn't update during runtime. So imagine that you've got constants in your code. It creates what's called a literal table to store the constants. It expands macros. I'm not going to go into what macros are right now, but all you need to know, it expands macros. And finally, it identifies, didn't mean to do that. It identifies procedures and functions, or the way they're called, system calls. So let's imagine that we had def hello. It identifies when the system calls functions, procedures, routines, whatever you want to call them. So it identifies when we've called the code. That is step one. All of those things.